Hello guys, in this video we are going to discuss the solution of the problem rat in a maze problem. So let us look at the problem statement. The problem statement says consider a rat placed at 0, 0 in a square matrix of order n by n. It has to reach the destination at n-1, n-1. Find all possible paths that the rat can take to reach from source to destination. The direction in which the rat can move is up, down, left and right. Value 0 at a cell in the matrix represent that it is blocked and rat cannot move to it, while value 1 at a cell in the matrix represent that the rat can be traveled through it. Note, in a path, no cell can be visited more than one time. If the source cell is 0, the rat cannot move to any other cell. In case of no path, return an empty list. The driver will output -1 automatically. So for instance, if this is the matrix which is given to us, the rat has to start from the source, which is 0, 0, this position, and it has to reach to its destination, which is this cell n-1, n-1. So in this case, the destination 3, 3 can be reached in two ways, which is down, right, and right. And the other direction is down, right, and right. Because of which we are printing these two paths. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution, let us take the matrix which we have. So this is the matrix which is given to us. We are at the starting position, which is 0, 0. And from 0, 0, as we have seen, we have four options available. So if we are at a cell I, j, we have four options available. We can go to up, we can go down, we can go left, and we can go right. So these are the four options which are available to us, and for all these options to be exercised, the corresponding value at the path, so value at this path should be 1. Similarly, the value at this location should be 1. The value at this location should be 1, and similarly the value at this location should be 1. And if the value at these locations are 1, then only we will be able to move to these paths. So let us apply the same logic over here. So we are at 0, 0 position. So we are at this position. And from this position, we have four options available. Clearly, we cannot go up, we cannot go right, and we cannot go left. Up and left we cannot go because it is going beyond the range of the matrix. And right we cannot go because the right cell is 0. So we have just one option, which is to go towards down. So let us go down. And if we go down, then the index changes to 1, 0, and let us indicate that we have moved towards down. Now once we have moved towards down, again we have four options over here. So we are at this position now, and from this position we have four options, again left, right, up and down. So clearly we cannot go towards left because we are going beyond the boundary of the matrix, but we can go up, we can go down, and we can go right. For this particular case, if you see, we don't want to go up because we have reached this position only from up. So in order to avoid visiting the visited path, what we are going to do is we are going to update the value to 0 as well. So what do I mean by this is, since 0, 0 is already visited, we are going to update this value to 0. Now once this value has been updated to 0, so from this position now only we have two options or two legal moves which we have, which is towards right and down, and that is what we are going to exercise here. So from here we have two options, which is right. So let's go towards right. So if we go towards right, the new index becomes 1, 1, and if we go towards down, the new index becomes 2, 0. And let us mark our path as well. So this is the case when we are going down, and this is the case when we have taken right. And again, since this value has already been visited, so we are going to mark it as 0. Now let's move forward. So from 2, 0, which is this cell, we have just one legal move, which is to go towards right. So let us exercise that cell. So this value will become 2, 1. And the way we were able to reach to 2, 1 is by taking the right path. And again, since we have already visited this cell, so we are going to mark it as 0. Now from 2, 1, which is this path, we have just one option, which is to go down. and we will exercise that path. So from 2, 1 if we go down, this becomes 3, 1 and this is down. And since we have already visited 2, 1, so we are going to update the value to 0. So this value will get updated to 0. So now we are at the cell 3, 1 and so from 3, 1 we have just one legal move, which is to go towards right. So this becomes 3, 2 and the way we have reached over here is by taking the right direction. And since 3, 1 we have visited, so we are going to mark it as 0. Now we are at this location and from this cell again we have just one legal move, which is to go towards right, and that is what we are going to follow. So this is 3, 3 and the way we are able to reach it is using the right direction. And since 3, 2 is already visited, so this becomes equals to 0. And in this way we will be able to reach to our destination. So the path we took over here, if you see, is down, down, right, down, right and right. So this is one of the path by which we were able to reach to our destination. Once we arrive to destination or once we encounter a dead end, in such case what we are going to do is we are going to roll back and all these values which we have marked it as 0 will become 1. So all these values will become again 1. And the reason why we are doing this is because it might be possible that when we will be iterating for the next path, we again might have to visit these paths, because of which we want these paths to be updated. So this will be the state of matrix. Just one more thing, folks. Here, so we want to start our exploration of the other path from this position. So which simply means cell 0, 0 and 1, 0 is already visited. So these two cells will be 0. So cell 0, 0 and 1, 0, since they have already been visited, and this will be the updated value of our matrix. We will see in code how are we going to tackle this, but for now let us proceed forward. So let us move to cell 1, 1, which is this cell, and from this cell we have just one option, which is to go towards down. So let us go towards down, and if you go towards down we will reach cell 2, 1. Now since cell 1, 1 is already visited, so we are going to mark it as 0. And then from cell 2, 1 we have two options available, which is to go towards left and to go towards right. So let us go towards left, and if we go towards left we will reach the position 2, 0, and if we go towards right we will reach the position 3, 1. And since cell 2, 1 is visited, so we are going to update this value to 0. Now as we can see, from cell 2, 0 there is no legal path, because of which we have encountered a dead end. Since we have encountered a dead end, we are going to roll back, and by rolling back we are going to update this entry to 1. So this entry was 0 initially. When we have visited 2, 0 we have made this entry as 0. Since we are rolling back, so we are going to mark this entry as 1. And since we are in the process of exploration of 2, 1 path, because of which we are not going to mark all other entries as 1. Now let us proceed forward. So from 3, 1, as we can see, so 3, 1 is this position, and since we have visited this, we are going to mark it as 0. And from 3, 1 where there is just one option, which is to move towards 3, 2. So let me update the directions. I missed to update the directions. So from 1, 1 we have moved towards down, and from here we have moved towards left, and from here we have moved towards right. And then from 3, 1 we are moving towards right. So now we are at position 3, 2. So let us update the value of 3, 2 to 0. And from 3, 2 we have just one legal move, which is to move towards right. And once we move towards right, we have reached our destination. I'm so sorry guys, this we have taken down path, right? From 2, 1 we have reached towards 3, 1, which is actually down. So let us now update our path. So the path we have taken is down, right, down, down, and then two rights. And in this way we have obtained this path and this path, and this and these two paths is what we are going to return to our driver code. So that's the discussion of the solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to find path and a matrix M is given to us. So what we are going to do is we will have an answer global variable, and initially the value is empty, and then we are going to check if matrix 0 comma 0 and matrix len of m comma. So essentially over here I am just checking whether my source and destination are reachable or not. So if these values are 1, then only the source and destination are reachable, otherwise it is not reachable. If this is reachable, then I want to find out the rat's path. So let us find out the rat path. And in order to find out the rat path, we need the matrix M. We need the starting position, which is 0 comma 0. We need a path variable. Initially the variable is empty, so this is a list. And we need the starting index of the path. So the first position where we want to insert the path is at 0th index. So this is what the arguments which the rat path takes. And this rat path function will update our answer. And then towards the end, we are simply going to return answer. Now let us look at this rat path function. So rat path, the matrix M is given to us, I comma j is given to us, and then I comma j we have a path and the index of path. Now the first thing which we are going to check is whether I and j is in the boundary of the matrix or not. So if I is less than 0 or I is greater than or equals to len of m, or j is less than 0 or j is greater than or equals to len of m. So if any of these conditions satisfy, that simply means we are going beyond the boundary of the matrix. In such case, we can simply return from our function. The third condition is essentially we will check if I equals to len of matrix minus 1 and j equals to len of matrix minus 1. This condition simply indicates that we have reached our destination, and if we have reached our destination, the values which are there in path, we are going to copy these values to our answer list. So let us do that. Answer dot append, and since we have to return path in the form of a string, and as of now the path is in the list format, so we are going to join this path. And how many values are we going to take from path? Well, the number of values we are going to take path is index values. Please note, it might be possible that the path has more than index values. In such cases, all the values exceeding index is not relevant for us. That is why we are bounding this by index. And in this way, we will be able to prepare our answer. And once we have prepared our answer, we can simply return from here. Otherwise, we are going to set m of I comma j equals to 0, since this cell has been visited. Just to indicate that, we are going to set it as 0. And once we have set this to 0, now we are going to check for 4 conditions, which is left, right, up and down. So we are at this cell I comma j, and we have 4 options available, which is to go towards up, down, left and right. So in each case, if we go towards up, then the new cell will be I plus 1 comma j. Similarly, if we go towards right, the new cell will be I comma j plus 1. If we go towards down, then the value will be I plus 1 comma j. I'm sorry folks, this will be I minus 1. Right, we are going up, so I minus 1. And if we go towards left, this will be I comma j minus 1. So this is what we are going to apply. So let us say we want to go up. So if we go up, as we know, I minus 1 we have to go to. So if I minus 1 is greater than equals to 0 and matrix of I minus 1 comma j is not equals to 0. In such case only we will be able to move to up cell. And once we move to up cell, then we are going to prepare our path, and we will look at the function prepare path later. But we will prepare our path, and to this function we are going to send path index, and since we have chosen an up direction, and once we have updated our path, then we are going to recurse on the. So let us recurse on the matrix. So to recurse on the matrix, all we have to do is rat path matrix. Now the new cell is I minus 1 comma j path, and since we have already consumed index, so the next index will be index plus 1. Similarly, if let's go down. So in case of down, I plus 1 should be less than len of matrix, and matrix I plus 1 comma j should not be equals to 0. So if these two conditions met, then we are going to prepare path. So I'm just indicating by pp, and to this we will just send path index and down. And once we have done that, then we are going to do rat path. So rp and m I plus 1 comma j comma path and index plus 1. And similarly for left and right condition. So let us go towards left. So j minus 1 is greater than or equals to 0, and matrix of I comma j minus 1 is not equals to 0. So in such case, we will prepare our path. We will send path index, and since we are taking left over here, so left, and then the rat path. So rat path will be equals to matrix I comma j minus 1 path and index plus 1. And the last case, which is to go towards right. To go towards right, j plus 1 is what we have to do, which should be less than length of m, and matrix of I comma j plus 1 is not equals to 0. In such case, we will prepare path, will send path index comma right, and then we will have our rat path m I j plus 1 comma path and index plus 1. And in this way we have iterated on all the 4 directions. And once we have iterated in all 4 directions, we just have to reset this value to 1, as we have discussed during the discussion of solution. And now let us look at the prepare path function. So for this, path was given, index, and a direction was given to us. So what we are going to do is, we are going to check if index is less than len of path. If it is less than len of path, then that particular value will be updated. So path of index will become equals to direction. Otherwise, path dot append. So this is exceeding the boundaries of path. So that is why path dot append direction. And in this way, we will be able to prepare our path. So that's the pseudocode of this problem, folks. Now let us see how we have implemented this in Python. So the Python implementation is same as our pseudo code. So over here we have an answer, and initially the answer is an empty list. If source and destination are reachable, then only we are going to explore rat path, and we are exploring rat path, and this rat path will update our answer, and towards the end we are returning our answer. Now let us look at the rat path function. So in the rat path function, the first thing which we are checking is whether I comma j is going beyond the boundary of matrix. If it is going beyond the boundary of matrix, then we are simply returning from the function. Otherwise, we are checking whether we have reached our destination. If we have reached our destination, then the path is being copied to our answer list. If we have not reached to our destination, then the cell which we have visited, we are marking it as 0. Then we are checking whether we can go towards up, down, left or right. If we can go towards these 4 directions, then we are preparing our path, and then we are recursing on rat path, and towards the end we are resetting the value which we have set 0 to 1. So that's the Python implementation, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.